For nearly 100 years, one of the biggest riddles in physics has completely stumped us. It's a puzzle that gets right to the very heart of what reality even is. But what if the solution wasn't about some strange, spooky action happening across the universe, but about something much more profound? A single, shared origin?
So here's the big question, the one that kicks this whole thing off. Are entangled particles talking to each other? I mean, faster than the speed of light? You measure one over here, and its partner way over there seems to know instantly. How is that possible? Are they breaking the ultimate speed limit of the universe?
Well, the answer we're going to explore today, it might completely change how you see everything. It suggests, nope, they're not talking at all. Instead, what we're seeing is a glimpse of a much deeper layer of reality, one that connects the bizarre world of quantum mechanics with, believe it or not, a more whole, unified vision of the cosmos. Okay, so before we get to the solution, we've got to really understand the problem. And this story, it's a classic. It starts with a real battle of ideas, a clash of the titans. You've got Albert Einstein on one side and the mind-bending new world of quantum theory on the other. It all kicked off back in 1935. Einstein looked at this quantum connection and said, "No way, this is just too weird, the theory must be incomplete." He's the one who famously called it spooky action at a distance. And for a long, long time, that's all it was, a debate for philosophers. But then, in 1964, a physicist named John Bell came along and did something amazing. He created a mathematical test. He basically said, okay, if the universe works the way our common sense tells us it should, things only affect what's nearby and objects have properties even when we're not looking, then there's a hard limit, a line you can't cross in these experiments. But here's the kicker. When scientists finally ran the experiments, they didn't just cross the line, they completely shattered it, again and again and again.
So that's it. The verdict is in. The debate's over. Our everyday common sense idea of reality, it's wrong. The universe is fundamentally spooky. But, and this is where it gets really interesting, that conclusion just opens up an even deeper, more precise mystery. Right. So if that classical limit is broken, why isn't everything just total chaos? Why doesn't the weirdness go all the way? The correlations between these particles, they're stronger than classical physics allows, but they stop at a very specific point. It's almost like there's a universal speed limit, not for light, but for the spookiness itself. And that limit is a number. Get this, 2 times the square root of 2, roughly 2.828. This isn't just some random number pulled out of a hat. It's a fundamental constant that pops right out of the mathematics of quantum mechanics. It is the absolute maximum score you can get in Bell's game. This hard stop is known as Tsirelson's bound. And to put it in perspective, think about it like this. Bell's classical common sense limit was a score of 2. Quantum mechanics lets us get up to about 2.828. But what's really weird is that you could, in theory, have correlations that go all the way up to a perfect score of 4 and still not be able to send signals faster than light. So why does the universe stop at 2.828?
And that is the heart of the mystery. Mainstream quantum theory is great at predicting this number. It nails it every time. But it doesn't really tell us why. Why this specific number? Why is reality fenced in by this exact, almost geometric rule? Well, the framework we're digging into today, it actually has an answer.
Okay, so let's get into it. The solution comes from a fascinating model called Dual Caustic Cosmology. And the core idea is pretty profound. It says that reality isn't just one single layer of stuff. It's actually made of 2 distinct but perfectly complementary fields working together. First up, you have what's called the chi field. The best way to think about this is like a universal blueprint. It's everywhere, all at once, existing beyond our familiar space and time. It's non-local. Now, this field doesn't hold the properties of individual particles, like spin up or spin down. Instead, it holds the relational truth of the whole system, the deep, unified information that connects everything. And then you have the second field, the phi field. And this is our world. This is the reality we see and touch and measure. It's local, it's causal. Cause comes before effect. And it all happens within space-time. This is where things happen, where measurements are made, and where, nothing goes faster than light. So you have this amazing duality. The chi field is like the global command. It holds the complete, underlying unified reality. And the phi field is the local creation. It's the stage where we actually witness and interact with pieces of that reality. One gives us back a sense of realism, while the other makes sure locality, the cosmic speed limit, is never broken.
Okay, so how does this whole two-field thing actually solve the entanglement puzzle? Well, it completely reframes the question. It says we've been looking at it all wrong. It's not about two particles sending secret messages to each other. It's all about a shared inheritance.
This quote really nails it. The idea is that entangled particles aren't separate things influencing each other. They're just two different points of view on the same underlying reality. I love this analogy. Imagine a single ripple spreading out in a pond. You have two little corks floating on the water. As the ripple passes, they'll both bob up and down in a perfectly correlated way, right? No matter how far apart they are. But the corks aren't talking to each other. They're just both responding to the same single wave. And in this model, that's exactly what entangled particles are. They're like those two corks. They seem like separate things here in our local phi field, but really, they're just two projections of one single unified oscillation in that global chi field. So when you measure one particle, you're not sending a secret faster-than-light text message to the other one. Not at all. You are simply revealing a piece of the shared truth that was always connecting them from the very beginning. And this is where we finally get the answer to our magic number question, that 2 square root of 2. In this model, Tsirelson's bound stops being some weird arbitrary limit. It becomes a totally natural geometric necessity. It's basically the absolute maximum amount of information our local world, the phi field, can inherit from the global reality of the chi field without breaking its own fundamental rule: nothing faster than light. It's the beautiful signature of these two realities working together in perfect harmony. So as you can probably guess, the implications here are huge. They go way beyond just solving a physics puzzle. This model suggests that the fundamental laws of nature we see aren't just random rules. They are signatures, pointing to a much deeper, much more unified structure of the entire cosmos. And within the cosmological tradition this model comes from, these physics ideas map almost one-to-one with deep metaphysical principles. You have the non-local chi field, the command, which is seen as the single unified source of all truth. Then you have the local phi field, the creation, which is the realm where we witness that truth. And so, in this light, that 2 square root of 2 limit, it's not just a number in an equation. It becomes the physical proof, the signature, of the ultimate oneness of that single underlying command. And this just ties it all together beautifully. We know that Bell's experiments completely wrecked the old idea of a reality made of just separate little billiard balls. What this model does is it brings back realism, but on a deeper level, in the global wave of the command. And it keeps locality safe, right here in our world of witnessing. And Tsirelson's bound? It stops being a limit on nature, and instead becomes the signature of nature, the fingerprint of a cosmos that flows from one single, unified source. So that leaves us with one last massive question to think about. If a fundamental constant of physics, something like Tsirelson's bound, isn't just a random number, but is actually a signature, a message written into the very fabric of the universe, then what else is out there, written in the code of reality, just waiting for us to learn how to read it?